Let's take a look at an application. And this will lead us into the logistic equation. Example 4, wildlife population. The rate of change of the number of coyotes, N of t, in a population is directly proportional to 650 minus NT, where N is the time in years. When t is equal to 0, the population is 300, and when t is equal to 2, the population has increased to 500. Find the population when t equals 3. Now notice that they've given us a point 0, 300. This is our time. This is our population. That's this one. And then they gave us another point. They gave us 2, 500. So this is t. Again, this is N of t, the population. And what they want us to find is this one. We know the t, and by this time we'll have N of t, and we can just substitute in and get our answer. Now, this verbal statement that we're reading here, this becomes this equation right here. The population, as it changes with respect to time, is proportional to 650 minus N of t. Some people like to see it written like this, just so it'll be a direct translation, but you don't want to write it this way. You don't want to introduce the extra bits of notation here. Just know that when they say N, they're referring to N of t. Okay, now let's solve this. We have to separate things out. Now it looks like I'm going to have N's and I'm going to have T's. It looks like the N's are going to be on the left side and the T's are going to be on the right side. K is a constant, so that one isn't an N or a T. It's just a constant. So what's happening here is I am going to, I'll take you through the steps they're doing. The dt, we multiply both sides by it, and that's how it's gone here. So I have dn is equal to k 650 minus n dt. This term here, the 650 minus n, that's an n term. So I'm going to divide both sides by 650 minus n. That's what you're seeing here. And then I'm going to integrate this. When I integrate this, let's do this side first. K is a constant. Think of there being a 1 there. You could think of it like this, right? Put the constant on the outside and there's just a 1. So that just becomes t and then times the k plus the c. On this side, this is a substitution problem where we let u equal 650 minus n, and that's going to give us 1 over u. But when we take the derivative, let's see, dn, sorry. When we take the derivative here, we get -1. So du equals -1 dn, and dn is equal to -1 du. So that's what you're seeing here. That's where you see a negative sign. Okay, so I'm going to get this side positive. So I'm going to multiply both sides by -1. And when I do that, let's see, I'm going to distribute this negative to both terms. So I get positive ln of absolute value of 650 minus n equals negative kt minus c1. All right, let's continue with this. You know what's going to happen. All right, we're going to do this. And so when we do that, you'll see that I end up with this. The the ln and the e are going to undo each other. And you'll notice that the absolute values are going to disappear here. It is a positive quantity that we're after. And so you end up with, let's see, yeah. So you end up with this. And as I mentioned before, if I have some base, let's say, I'll show an example of 2, of 3 plus 5, remember that means, write it all out. It means the same as this. Okay, that's why you're seeing this step turn into this. So actually, this turns into this right here. And they do a lot of step skipping. It drives me nuts here. They've done a couple of things. So they have taken this and subtracted it on both sides. They have taken this and subtracted it on both sides, and they've added n on both sides, and then they switched the positions. So n is equal to 650 minus this, which becomes this. Okay, and now we're ready to start the solution here. Remember that we were told, we were given a point, the point 0, 300. And so when we do that to this equation here, here's what happens. So 300 equals 650 minus c e to the negative k times 0. K times 0 is 0, negative 0 is 0, e to the 0 is 1. 1 times c is c, so you get 300 equals 650 minus c. I am going to subtract the 300 on both sides, and I'm going to add c on both sides. And I'm going to end up with c is equal to 350. And so now where we had c, we're going to put 350. And so this brings us closer to the solution that we're looking for. So that's where the 350 came from. Now we were given another point. We were given the point 2, 500. And so now we're going to take this 2 and this 500 and plug it into here and here. And that's what you see here and here. And then work that out, and you see that k is equal to this. And now we're going to take that and plug that into this model, and we have the actual model we were looking for. Now we can use that to plug 3 in. And this is written wrong. When this thing translated the slide, it took everything out of where it's supposed to be. It's supposed to look like this. This is supposed to be in the exponent, the power. And it turns out to be 552 coyotes. And here's what the graph looks like. And you can see that at 3, go up, that's where they get that from. Now, a couple of things, and this will set us up for what's coming next. So n equals 650 is a horizontal asymptote for this graph. I mean, they didn't write it in, but if we drew it in here, there's this line, and they call this line L. And it's referred to as the carrying capacity of this particular model. And you'll see what that means in the next video.